Hello and welcome to Algebra 2, Chapter 2.1. We're starting Chapter 2 today. It is linear equations and functions. And 2.1 is what we're discussing, which is functions and their graphs. So starting out with a few definitions, a relation is a mapping or pairing of inputs and outputs. So lots of times our relations come as ordered pairs because it's a mapping of some input to some output. Relation doesn't have to be just numbers. It can be quantities. For instance, in Kansas City today, maybe it was 50 degrees. And in St. Louis today, maybe it was 65 degrees, and it's just some input and output. The domain is always going to be these input values, so this first spot is our input. Lots of times it's a value, it's a number, but in my example of cities, it could be cities. Okay, just whatever is your input. Your range is your output, so it's this other side. Okay, and again, it could be a numerical quantity or it could be some sort of description. And so we have a function when we have a relation where there's exactly one output for each input. So if I input Kansas City into the place, is it always going to output 50 degrees? No, so that's not going to be a function. But if I have y equals 2x, and I input 4, is it always going to output 8? Yes, so that's a function. Is the output always the exact same for the input? So one way to show a mapping, I showed it with ordered pairs, but one way to show a mapping is using these kind of ovals that we draw lines or arrows to represent. This is actually called a mapping. So identify the domain and range and then tell whether each one is a function. So your domain is going to be which values are in the input. So this would be -3, 2, and 3. And our range is going to be which values are in the output. So -2, 1, and 3. And the question is this a function? So does every input have just, so if every time I do -3, do I get 1? Every time I do 2, do I get 3? Every time I do 3, do I get -2? Looks like it. So yes, this one is a function. Now looking at the other ones, we can still do domain and range the same way. So domain is your input. And typically you do these in alphabetical order. So they're listed in alphabetical order for us, which is nice. -1, 1, and 3. So there's my domain and range. Is this a function? So every time I put in -3, do I get 1? Right? Every time I put in -1, do I get 1? Every time I put in 2, do I get -1? As is, this is a function. Now, I happen to believe, I think he lost a few of his arrows. What would happen if we put that in there? So 1 maps to both 1 and 3. Then is it still a function? With that in there, it's not a function because 1 maps to 2 different outputs. So we want each input maps to 1 output. That's a function. So quick review of ordered pairs, graphing on a coordinate plane. Ordered pairs must come in parentheses with a comma in between them. Your x-coordinate always comes first. Your y-coordinate comes second. X-coordinate is your horizontal axis. Y-coordinate is your vertical axis. And when you go to plot points, let's say we plot 2, 3, you're going to move x first and then y. So we're going to move to the, let's see here, from starting at the origin, we're going to move, you're going to move right 2 and up 3, and you don't really draw that in, but so you can see where I went. And you're going to try to get it on the coordinate. All right, so remember your origin has ordered pairs 0, 0. 4 quadrants, you name your quadrants with Roman numerals. They are 1, 2, 3, and 4. Sound good? Okay, so I can take a mapping, so this is a mapping. I can take a mapping and I can graph it. So this just says graph the relations. So we're going to do -3, 1. So I'm going to go over -3, go up 1. There's -3, 1. And then we have 2, 3. So over 2, up 3. And 3, -2 over 3, down 2. There we go. And we did say that was a function. Okay, keep that in mind. I want you to graph this other one, and then notice, according to the video anyway, we got those extra arrows in there. Is that a function? Take a look at that, and we will talk about that one in class. Make sure you have that one graphed. So we need to be able to tell from a graph if something's a function or not. And to do that, we have what's called the vertical line test. And it says that a relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. So we could talk just points, but sometimes it's nice to talk maybe something other than points. So let's say we have a circle and a line. Is the line a function? It is, because if I draw vertical lines, they're each only going to go through that graph once. Okay? Is a circle a function? No, because those vertical lines are going to go through it in 2 places. Right? So that is a quick look at a graph. Vertical lines go through it once. It's a function. More than once, not a function. So here we have a graph of beachgoers. We have a temperature and the number of visitors. And it says, is this a function? So I can just look and go, well, look right here. Is that a function? No. Okay, and then it says explain. Well, probably the easiest explanation would be, let's do doesn't pass vertical line test. And if you think about it, you know, every time it's 86 degrees, is the exact same number of people going to be on the beach. You know, every time it's 87 degrees, is the exact same number of people going to be on the beach, right? No. You know, what happens if it's the 86 degrees during the summer or during the fall, or it's during a school day? So, I mean, this should make sense that this one is not a function. So we're talking a little bit about evaluating functions. And functions can be represented as an equation in 2 variables, because remember we need to have an input and an output. And so a solution is going to be any ordered pair that makes this true. And for linear equations, really you could have infinitely many ordered pairs that make it true, because remember if you graph a line, and if I graph a line, every single ordered pair on that line is a solution of that line. So I can have infinitely many solutions here. And so the graph, what we graph, so here's what I just graphed, is all the solutions. You're graphing all the solutions that are true in that equation. And so then how do I graph something? Well, if we're talking a line and you remember how to graph from slope-intercept form or something, I would definitely use that. But what if we're not talking a line? A table graphs everything. If I give you something crazy, silly that you've never heard of before, we can make it a lot crazier than that. But if I gave you that and said graph it, and you're looking at it and you're like, I have no idea what that graphs. Make a table. A table graphs anything and everything because you have input values and you have an output value. And if you get those organized in your table, you plot them, you know what you're graphing. So I actually want you to do this one on your own. Either make a table, or if you remember slope-intercept form, up to you. We will go over it in class, but I want to see, so you might take a second now, pause, and make sure you can graph that. So our last little bit that we're going to talk about, this chapter is called linear equations. So a linear function, linear, does graph a line, and hopefully you realized that in that last example you did get a line. Lines are in the form y equals mx plus b, also called slope-intercept form. M and b are constants, so they're numbers, so x and y are variables. And at any time, if you're talking about a function, you can replace y with f of x. So this is the function of x, or the function with respect to x, meaning that x is my variable. And you want to know that because if I'm looking here, there's really 3 different letters. Which one of those letters is my variable? It tells you right there which one of those letters is your variable. And so we will use f of x to really say, you know, I know this is a function, because functions are sometimes more important than something that's not a function. And then specifically, I know what variable I'm talking about. So both of these, all of these are functions. I want to know whether they're a linear function or not. Decide whether the function is linear. So is f of x equals x squared plus 4x minus 1 a linear function? It is not. Do we know why it's not a linear function? Has an x squared in it. You just wrote that a linear function is in the form mx plus b, and there's no x squareds in there. So if I have an x squared, that's not a linear function, okay? But we can still evaluate it for 3. So to evaluate it, we're going to call this f of 3, and that means we're going to do 3 squared plus 4 times 3 minus 1, which is 9 plus 12 minus 1. 9 plus 12 is 21, minus 1 is 20. Okay, notice I didn't do anything really with that 3, but the 3 told me what to put in for x, and thus I put that in for x. What about g of x equals negative 3x plus 4? Is that a linear function? Yes, it is linear, right? We have mx plus b, and we can evaluate this for 3 as well. We get negative 3 times 3 plus 4, which is negative 9 plus 4, which is negative 5. So when you evaluate, you're just going to get a single number answer. Okay, and the other part real quick, I want to talk about domain and range. For this first one, can you put anything you want in for x? Is there any restrictions? There's not. You can put in anything for x. And same thing for g, right? Can I put in anything for x? So we say domain is going to be all real numbers. And what about range? If you can put in anything for x, will you always get everything out for y? I mean, is it always going to be positive y's? Is it always going to be even y's? Or can you really get anything out for y? Well, for the second one, you could get anything out for y. For the first one, you're not going to be able to get anything out for y. Tell you what, we're going to leave that one open for us to discuss later, because sometimes you need a little more than just looking at it to figure out what that range is. Okay, so that's what I have for you for 2-1. Let me know if you have any questions, and if not, we'll see you in class. Have a great day.